There's a bottle under almost every kitchen sink in the world that, if mixed with the wrong thing, can put you in a hospital bed within minutes. And most people have no idea they're one careless pour away from it. We're talking about ordinary household items, not exotic poisons, not lab chemicals you'd need a permit for, just things sitting in garages, bathrooms, and cleaning cabinets right now. And the scary part is, almost nobody reads labels carefully enough to know which combinations turn harmless into hazardous. Here's the problem. Every year, poison control centers field hundreds of thousands of calls related to chemical exposure at home, and a huge chunk of them aren't from people doing anything reckless on purpose. They're from someone trying to clean a bathroom faster, or get rid of a smell, or kill mold, and accidentally combining two products that were never meant to meet. The instructions on the back of a cleaning bottle are tiny, often vague, and almost never explain the actual chemistry of why something is dangerous. So people improvise. And improvising with chemistry is exactly how accidents happen. What most people don't realize is that danger isn't always about the substance itself. It's about combinations and conditions. A chemical that's perfectly safe to use alone can become something completely different the moment it touches another common product, or gets heated, or sits in a sealed space too long. That's the overlooked piece most online tips like substances you should never touch leave out. They list the substance, but skip the context that actually makes it risky. To understand why, it helps to go back to how a lot of these chemicals entered everyday life in the first place. Many of today's household cleaners and industrial substances were developed in the early to mid-20th century for factories, hospitals, and wartime production. Saltrates now, things like chlorine-based disinfectants and ammonia compounds, were prized because they were cheap, effective, and powerful. Over decades, they got repackaged into friendly plastic bottles with cartoon labels, and the industrial-strength chemistry behind them slowly faded from public memory. People stopped treating them with the same caution a factory worker once would have, because marketing made them feel like furniture polish instead of what they really are, reactive compounds. The science behind why these reactions turn dangerous is actually pretty simple once you strip away the jargon. Bleach, for instance, is essentially sodium hypochlorite in water. On its own, it's a strong disinfectant. But combine it with an acid, like many bathroom or toilet bowl cleaners, and you trigger a reaction that releases chlorine gas, the same gas that was weaponized in early 20th century warfare because it attacks the lungs almost instantly. Mix bleach with ammonia instead, and you get chloramine vapors, which irritate the respiratory system severely, even in small amounts. Think of it like mixing two calm dogs that are fine separately, but turn aggressive the moment they're put in the same room. The individual substances aren't inherently evil. It's the interaction that creates the threat. So why doesn't anyone warn you about this clearly? Mostly because of how the cleaning and home goods industry is structured. Companies aren't incentivized to print "this could kill you if combined with that competitor's product" on their packaging. It would scare customers and invite lawsuits, even though the underlying chemistry is well documented in safety data sheets that almost nobody outside of industrial settings ever reads. Hidden Fix Lab pulled some of these directly from manufacturer safety documentation, the kind meant for warehouse workers, not the average homeowner. The information isn't secret. It's just buried in places ordinary people never look, written in language designed for professionals, not parents doing weekend cleaning. Industrial hygienists, hazmat responders, and ER toxicologists deal with the real-world consequences of this gap constantly. Emergency rooms across the country see a predictable spike in chemical exposure incidents tied to home cleaning, especially in colder months when windows are shut and ventilation drops. Firefighters responding to mystery gas calls in residential buildings frequently trace the source back to two cleaning products poured into the same bucket. These aren't rare industrial accidents. They're everyday households learning the hard way that chemistry doesn't care about good intentions. So here's how you actually protect yourself and your family, in practical terms. First, never combine bleach with ammonia-based cleaners, vinegar, rubbing alcohol, or any acidic cleaning product. Keep bleach completely isolated from your other cleaning supplies, on a different shelf if possible, so there's zero chance of accidental contact. Second, treat any product labeled with words like corrosive, caution, or danger as something that needs its own dedicated, well-ventilated space. Never store these in unmarked containers, and never transfer them into old food or drink bottles where someone could mistake them for something safe to taste or inhale. Third, when using any strong chemical indoors, open a window or run a fan. Ventilation is the simplest, cheapest safety tool that almost nobody actually uses. Fourth, if you ever notice a strong, sharp, or sudden chemical smell after mixing cleaning products, leave the area immediately and get fresh air. Don't try to wait it out near the source. And finally, always store substances like drain cleaners, pool chemicals, pesticides, and old paint thinners well out of reach of children and pets, ideally in a locked cabinet, since these account for a disproportionate number of accidental poisoning cases every year. It's also worth being realistic about limitations here. This isn't a complete list of every dangerous combination that exists, and no script can replace actually reading the safety information that comes with the products in your home. Some reactions depend on concentration, ventilation, and even temperature, so what's mildly irritating in one scenario can be more serious in another. If you're ever unsure about a chemical, the manufacturer's safety data sheet, usually available with a quick search, is far more reliable than guesswork. At the end of the day, the substances themselves aren't villains in some hidden conspiracy. They're just powerful tools that demand a level of respect most of us were never taught to give them. The real shift isn't fear, it's awareness. Knowing what's under your sink, understanding how things interact, and giving 5 extra seconds of thought before mixing anything is the difference between a normal Tuesday and an emergency room visit. Sometimes, the most dangerous thing in your house isn't some rare substance locked away somewhere. It's the ordinary bottle you've walked past 1,000 times without ever really looking at what it says.